Hi everybody, we are going to be talking about the mean value theorem, and we're going to do an example that has you use the mean value theorem. So the mean value theorem says if f is continuous on the closed interval ab and differentiable on the open interval ab, then there exists some c on that open interval such that the derivative equals the slope of the secant between a and b. So let's draw a picture of this because I think that's going to help it make sense. So on a graph, I'm just going to choose some x value a and another x value b. And I also want f of a and f of b. Now, if f of a equals f of b, you can still use the mean value theorem, but you can also use Rolle's theorem, which is a special case of the mean value theorem. So for our drawing today, let's make f of a and f of b different, so not equal to each other. So I'm going to have a f of a, b f of b. Now, if f is continuous and differentiable on that interval, I'm just going to say we have some, I'm going to make it some continuous function. Okay, now this second part of this equation is the slope of the secant line that connects a f of a and b f of b. So if I draw a straight line, the slope of this line, think y2 minus y1 over x2 minus x1. Notice that is the right side of this equation right here. So what mean value theorem says is if we're continuous and differentiable on the interval, then there must exist somewhere in this interval a value, and I'm just going to pick maybe right here, such that the derivative of the function at that value c is equal to this slope of the secant line, f of b minus f of a over b minus a. And you can kind of see that this slope looks like it's the same as the slope of this line right here. So that's what mean value theorem is saying. Let's do an example. So where might I need to use this? Let's give a function. So let's verify the conditions for MVT, and let's find the value c on the interval. Let's say my interval is 0, 2. Okay, so first thing I want to show is that f is continuous on the interval and differentiable on the open interval. So f of x in my example is a polynomial. Polynomials are continuous and differentiable everywhere. So I'm going to say f is a polynomial. Then f of x is continuous, and I want to show my specific interval. So it's continuous on this closed interval 0, 2, closed interval, and differentiable on the open interval 0, 2. So just because of those two things, I can say, therefore, by the mean value theorem, there exists a c on the open interval such that the derivative of the function at c is equal to, and I'm going to put my numbers in there, the slope of the secant line. Once we have all of that written out, let's actually find that value c. So first thing I'm going to do is I'm going to find my first derivative. Okay, and I'm going to say, I'm going to plug in my c. So the first derivative at c, that's this part right here, that is going to equal the slope of the secant. So we can figure out f of 2 if we want to do it on this side. F of 2 is going to be 2 cubed plus 2 minus 1. That's going to be 10 minus 1, which is 9. F of 0 is going to be -1. So 9 minus -1 all over 2, we're saying is going to equal 3c squared plus 1. And keep in mind, this is us saying f prime of c equals this, b minus a. So let's simplify our right side. This is going to be 10 over 2, which is 5. Solve for c. Okay, so c is plus or minus 2 over rad 3. But be careful, we are asking about the interval 0 to 2. So this answer suggests positive 2 over rad 3 and, oops, don't want to write it like that, and negative 2 over rad 3. Negative 2 over rad 3 is not in the interval, so we are not going to put that as one of our answers. We're going to say just the value c equals 2 over rad 3 is our value c on that interval. So there's an example of the mean value theorem.